Good afternoon, dear students. I am here before you again, presenting another question from the miscellaneous exercise for class 12 integrals. So I have chosen the question number 26th, which states to evaluate the value of the integral extending from 0 to pi by 4 sin x cos x divided by cos to the power 4x plus sin to the power 4x dx. So basically the integral says that we have to find the integral of the integrable function, or we have to find the area subtended with the x-axis of the functional graph sin x cos x divided by cos to the power 4x plus sin to the power 4x. Understood? And the boundary points are 0 to pi by 4. So I have already illustrated the procedure. My answer I have written it already. I am explaining it to you now. So the function is sin x cos x divided by cos to the power 4x plus sin to the power 4x. Here is the function. Now the denominator I am writing it in a simpler form as cos to the power 4x plus sin to the power 4x plus 2 sin square x cos square x minus 2 sin square x cos square x. I am just adding and subtracting the same quantity from the denominator, and it does not change or alter its magnitude. And hence I obtain, since a square plus b square plus 2ab format the first three terms in the denominator, you can see it's cos square x plus sin square x whole square. So I have simplified it, and minus 2 sin square x cos square x. Carefully look at the denominator, what I have done. And we all know that cos square x plus sin square x is nothing but equals to 1. So I have written I is equal to the integral from 0 to pi by 4 sin x times cos x divided by 1, because cos square x plus sin square x whole square 1, minus 2 sin square x cos square x. So I obtain. Now what I do, I multiply 4 in the numerator and 4 in the denominator. We have to use some intelligence or some type of material instincts or mathematical allegories in order to solve such kind of problems, because we need to find a function which replaces a simpler function. We will see later why I have multiplied this 4 in the denominator and numerator. It will become evident in the subsequent steps. So now listen, you multiply 4 in the numerator and multiply 4 in the denominator. 4 sin x cos x divided by 4 into 1 minus 2 sin square x cos square x dx. The integration is from 0 to pi by 4. So that implies my integral is, now look carefully. Suppose I take the function cos 2x. Now if I differentiate cos 2x, what will I obtain? It's minus 2 sin 2x, which is nothing but minus 2 of 2 sin x cos x, which is nothing but minus 4 sin x cos x. Understood? This is the derivative of cos 2x. This numerator is nothing but the negative of the derivative of cos 2x. So what did I do? I took this derivative, replaced it by the derivative of cos 2x, and the minus sign I have taken it outside, and I have multiplied, and what I have done in the denominator, I have multiplied 4. I split it into, since 1 by 4 is equal to 1 by 2 into 1 by 2, I have split it into 1 by 2 out of the integrand and 1 by 2 inside the integrand, and the minus sign outside of the integrand. I have sent it out. Understood? So why I have done this? See in the subsequent step. So I is now what? Minus half, and the integral extends from 0 to pi by 4 d of cos 2x. It is evident here. and x ranges from 0 to pi by 4. So now I multiply this 2 with the 1 minus 2 sin square x cos square x polynomial. So I obtain 2 minus 4 sin square x cos square x. Understood how it happened? Now let's see. In the next step I have written I is equal to minus half. Okay children, okay students, okay children, if you are not able to understand, I am again explaining in a new page. What basically I have done, I multiplied 4 in the numerator and denominator. That point you all got or not? I am not writing the limits now. Look carefully. And in the denominator what I had? 4 into plus 2. Yes, 1 minus. Wait a minute. In the denominator I had 4 into 1 minus 2 sin square x cos square x. Yes or no? Now this minus I multiplied and minus I multiplied outside. It becomes plus. Now this is the derivative of cos 2x. This is the derivative of dx. So this is the derivative of d of cos 2x by dx is nothing but minus 4 sin x cos x. Since this is the derivative of cos 2x, I write it as derivative of cos 2x. And this 4 here, now I can write it as 2 into 2, 1 minus 2 sin square x cos square x. Now what I did, minus is here, already minus 1 is here. So minus 1 by 2. 1, 2 I sent it out. And I simply arrived at this format. Now is it clear to one and all? Everybody is now convinced? Is everybody convinced by now? I hope so. Okay. I just did it. Minus half into d of cos 2x divided by 2 into 1 minus 2 sin square x cos square x. How you understood? Simple alterations in the integrand I am able to reach. Understood? Now let's go to our main segment. So I arrived at this format. D of cos 2x divided by 2 minus 4 sin square x cos square x. The integrand is from 0 to pi by 4. Minus half is outside the integrand. Okay? Now the denominator I have 2 minus 4 sin square x cos square x. I can write it as 1 plus 1 minus 4 sin square x cos square x. 2 is 1 plus 1. So now carefully see. We know that cos square x plus sin square x is equal to 1. So cos square x plus sin square x whole square is also equal to 1. So I can again write it as 1 plus cos square x plus sin square x whole square minus 4 sin square x cos square x. So now my integral I is equal to minus half the integrand ranges from 0 to pi by 4 d cos 2x, and this is nothing but equal to 1 plus cos 2x whole square. Why? I have written here, you know an identity, you must have studied an identity, a plus b whole square minus a minus b whole square is equal to 4ab. Isn't it? Very simple identity. Now I simply use that identity here, children. Simply that identity. Here a is equal to cos square x. Here a is equal to cos square x. B is equal to sin square x. And I have, since cos square x plus sin square x whole square, cos square x plus sin square x whole square minus cos square x minus sin square x whole square is equal to 4 into a is cos square x, b is sin square x. So 4ab, a plus b whole square minus a minus b whole square is equal to 4ab. Understood? So since now this transforms into cos square x minus sin square x whole square, and cos square x minus sin square x is nothing but cos 2x. So hence I arrive at the I is equal to minus half. The integral ranges from 0 to pi by 4 d of cos 2x divided by 1 plus cos 2x whole square. Why? Because cos 2x is equal to cos square x minus sin square x, and cos square x minus sin square x is equal to cos square x plus sin square x whole square minus 4 sin square x cos square x. Using the simple identity, algebraic identity, a plus b whole square minus 4ab is equal to a minus b whole square. I have written it here. Understood? So now we know that dx by 1 plus x square integral is equal to tan inverse x plus c. We know it's an indefinite integral form, so it's nothing but here the variable is cos 2x. It's in the form of cos 2x. So tan inverse cos 2x will be the indefinite integral, minus half is here, and the limits are from 0 to pi by 4. So if I substitute pi by 4 here, it will give me cos pi by 2. Cos pi by 2 is 0, tan inverse 0 is 0. If I substitute 0 here, it will give me tan inverse cos 0, means tan inverse 1. And since range of tan inverse function is minus pi by 2 to pi by 2, so tan inverse 1's principal value is pi by 4, tan inverse 0's principal value is 0. Understood? So minus half into 0 minus pi by 4, which gives me pi by 8. So hence my integral is, the value of this definite integral is pi by 8. I hope everybody is clear about this question. So basically this step you have to understand. How I transformed this 4 sin x cos x into minus d cos 2x, and why I splitted this 4 into 2 into 2, took 1 2 out of the integrand, took 1 2 inside the integrand, so that I can obtain it in the form of the integrand as d of a variable divided by 1 plus that variable whole square, which will give me tan inverse of that variable. And here I use the identity cos square x plus sin square x whole square minus 4 sin square x cos square x is nothing but cos square x minus sin square x whole square, which is cos 2x whole square. So we need to have some intuition, and we need to spread our arena, our brain's limitations to such a large extent. We have to indulge in all areas of mathematics while solving these integrals, definite or indefinite. Understood? Because no property of the definite integrals can be used in such questions, we need to evaluate the indefinite integral and subsequently substitute the limits. I hope everybody is clear about this question. How we got pi by 8, obtained pi by 8 as the solution of this definite integral of the function sin x cos x divided by cos to the power 4x plus sin to the power 4x. Is everybody clear? Okay. Thank you so much. I will be back soon with further questions. Thanks.